Data management we are going to talk about. It's a very interesting and important topic. Although this presentation is going to be a bit monotonic, it's not having very much graphics into it today. Although till now, whatever sessions I have taken, that was having graphics. But for today, like forgive me because simply this concept is not that much graphical, which I would have taken multiple images there. I can take, but it was not having that concept there. But yes, we will be working with it. So simply the data collection, storage and analysis. That is our today's concept, and it is a very big concept which we won't be able to complete in one session. It will be going for multiple sessions, multiple lectures. So simply IoT data management, that is data collection, storage and analysis, that how we maintain the data, how we manage the data in IoT, understanding the role of cloud computing in big data analytics in IoT. You can say that big data is definitely there. Okay, big data, cloud computing and IoT, their connectivity, their collective approaches we are going to talk. Now, first thing which comes here into the picture, that is the content that what we are going to actually cover. So introduction to IoT data collection, sensors and data acquisition, data transmission protocols we will talk about, then edge computing, introduction to IoT data storage, cloud computing in IoT. This is the work which we will be doing in the upcoming sessions. Like this is a complete stuff which will be covering 2-3 sessions at least. Then popular cloud platforms for IoT, then IoT data security, data encryption and security protocols we will do, introduction to IoT data analysis, big data analytics in IoT. Then simply we will be going for data processing techniques, machine learning and IoT. Case studies we will see multiple IoT data management case studies. Then challenges in the IoT data management, what comes, that we will discuss. Then future trends in IoT data management and best practices for the IoT data management. These 18 table of content which you can see are here. This we will be covering and it will be taking multiple sessions to be done. Today we will be starting with the first part, that is the introduction to the IoT management, IoT data management. So simply introduction to the IoT data management when we talk about, so there are few steps to be taken here. First one is the data collection and aggregation, then data storage and organization, then data processing and analytics, then data security and privacy, and then data integration and interoperability. So data collection and aggregation, data storage and organization, data processing and analytics, data security and privacy, and data integration and interoperability. So these are like all connected concepts and they are self-explanatory. You can understand this with the name only, that okay about what we are talking. But yes, we will be definitely doing these things in a very detailed manner. So first of all, we will be talking about the first point, which was there, you can see, and keep taking the screenshots for the references. Data collection and aggregation is the first one. So data collection and aggregation, when we talk about, so IoT devices generate vast amount of data from sensors, cameras, and other sources. Okay, so simply managing this data involves collecting and aggregating it from various devices, often in real time. So efficient data management ensures that this data is accurately captured and made available for processing. That is the process of data collection and aggregation, that what you are taking, what input we are getting from the different sensors, cameras and sources from very vast amount of devices when we get the IoT data. So simply how we manage them in the real time, that is the point. Then data storage and organization comes into the picture. So the enormous volume of IoT data requires robust storage solutions. Obviously, a lot amount of data is there, so there is a requirement of the storage solutions also. And data must be stored in a way that allows for easy retrieval and analysis. So the data should be stored somewhere. That's why when it is stored, so there is a requirement for the management of the data also. When you are storing it, so you need to manage it also. So simply data must be stored in a way that allows for easy retrieval and analysis. So simply it should be stored in such a manner that we are able to analyze it. We have to retrieve it for the analysis process. So that is there. Then this often involves using cloud storage databases, like cloud storages, databases, and distributed storage systems designed to handle the scalability need of the IoT applications. So simply the different vast amount of data is there. So obviously their storages are also different. cloud storage is there, normal storages are also there on the systems and all when you access it on the local storage or mobile storage. So simply that is distributed, and distributed storage system designed is the design is there to handle the scalability. Then the data processing and analytics comes into the picture. So once the data is collected, IoT data must be processed to extract meaningful insights. Like, what is the meaning of just collecting the data? We have to collect it, we have to manage it, and then we have to process it also. For processing is done for the different analytics. So simply the meaningful insights are extracted. So this involves filtering, clearing, and analyzing the data, often using advanced analytics and machine learning techniques. You will be also learning the machine learning. I will be giving you the resources for it that will be discussed here, and that part you have to do. So simply the real-time processing is crucial, and it like in many IoT applications such as predictive maintenance and automated decision making, the real-time processing is necessary. And real-time processing is done with the help of the different techniques, the machine learning implementations and all, with the help of which we will be able to do it in the real time. Otherwise, how we will do it? Simply the coding which we do, we will be able to get, like, simply input is coming and that input we have just processed directly, and directly maps and insights we are able to get, the graphs and all. That is the real time. Then the security is also necessary when you are having the data, when you are maintaining the data, when you are processing the data, when it is necessary, the insights are getting maintained and all. Then obviously it's also necessary that your data is secured and you are having the privacy of the data. The data should be not, it should have some privacy also, security also. So simply, IoT data often includes sensitive information, making security and privacy critical. So managing IoT data involves implementing encryption, access control, and other security measures to protect the data from unauthorized access and breaches. So managing of the IoT data involves implementing encryptions, access controls, and other security measures to protect the data from unauthorized access and breaches. Now, compliance with regulations like GDPR is also important. GDPR is General Data Protected Regulation. Okay, GDPR is General Data Protected Regulation. One of the purposes of GDPR is to protect individual fundamental rights and freedoms, like particularly their right to protect their personal data. That is the GDPR, and there are seven principles also of the GDPR. So simply lawfulness. You can write them down. It's not present in this presentation. So you can write down that what is GDPR. Please write down GDPR. That is the General Data Protection Regulations. GDPR stands for General Data Protection Regulation. So you can write down, please, that GDPR is to protect individual fundamental rights. GDPR is the process to protect individual fundamental rights and freedom. I'm repeating, GDPR is General Data Protection Regulation. It is a process to protect individual fundamental rights and freedoms, particularly their right to protection of their personal data. Okay, right to protection of their personal data. Then you can write down the 7 principles of GDPR. You can write down the 7 principles of GDPR. Heading 7 principles of GDPR. 1. Lawfulness. 2. Fairness and transparency. 1. Lawfulness. 2. Fairness and transparency. 3. Purpose limitation. 3. Purpose limitation. 4. Data minimization. 4. Data minimization. 5. Accuracy. 6. Data storage limitation. 6. Data storage limitation. 7. Implication and confidentiality. Implication and confidentiality. And you can write 8th also. Accountability. Okay, accountability. So these principles are found right at the outset of the GDPR and inform all other provisions that are legitimated. Okay. Now the data integration and interoperability is important to understand. Simply, IoT ecosystem often consists of diverse devices and systems from different vendors. Okay, different type of vendors, different products are there. Like I told you about the Bolt IoT, Raspberry Pi, Arduino. There are many. And they all are the diverse devices which are actually used in the connectivity, that micro sensors are there, controllers are there. So they all are from different vendors, different devices are there, which are connected in one ecosystem of IoT. So effective data management requires integrating data from various sources and ensuring interoperability between different systems. Okay, that is effective data management. And this enables seamless communication and data exchange, facilitating a unified view of the IoT environment.